So we're talking about biology. And as a social worker, why should you care? Well, one, on the cellular level, if you remember your biology, there was the nucleus, the mitochondria, all these little organelles, right, that operated inside the cell. They all operated independently, but they really only made sense because they were interdependent in their jobs. And a cell also has a boundary that protects from bad toxins from coming into the cell and from valuable toxins leaving, and it can make it permeable if it needs to, semi-permeable, or impermeable, which is a very cool metaphor for how we see the individual with inside the environment. But that's just on a metaphorical level why we should care about biology. We care about biology because one of the biggest questions we have is why do people do what they do and what can help people change? If I believe that people are controlled by childhood experiences, then that's what I'm going to focus on. If I believe that depression is a learned behavior, I might focus differently on that. If I think that depression or anxiety is a neurochemical imbalance per se, then I might be focusing it differently. So part of it helps us understand human behavior and also helps us understand what might help. And it gets down to the biggest question, which is, are we who we are because of nature or because of nurture or a combination? And if it is a combination, what level of combination? And can we impact that? Can we affect it? Make changes of some kind? Am I destined to be the person I am? Am I destined to have the relationships I have? Am I destined to have the moods? Am I destined to have the illnesses or the health? Because social work is also really keen on social and economic justice, and we really see the impact the environment has on the individual and the individual's impact on the environment, what does that have to do with biology? Well, a number of things. One, does changing my environment change my health? If so, how? Well, it does turn out that you can really predict somebody's health and how long they will live based upon their zip code. And it turns out, like other things in our society, those who have better resources do better. They have clean water, they have clean air, they have clean environments. A big part, their lives are less stressful, either because they feel safe on the street or because they make a living wage or because they feel like they have more control at home and at work, because they feel liked and welcomed into this world. All of those things impact their level of health. I was working with a client, and all I knew is that he was new to the area. And then at some point, he describes having asthma and also having learning disability. And so at some point, I asked him, "Did you come from back east in a large city?" And he said, "Yeah, I'm from Detroit." And it was a guess, and it's not a good diagnostic tool, and I'm not telling you this story because of that, but to tell you that, wow, patterns really are strong, is that, yeah, lots and lots of studies show that if you live in an urban area around bus stops and truck stops and places where those big, large vehicles have to run many hours, even when there's no one there, that, especially the stations, that you're going to be more likely to have asthma. The same is true as where the city dump is. And if you notice, where is the dump? Where are the toxic chemicals? Where are the train stations and bus stations and truck stops? Where are they? Well, they may not be in your neighborhood, or you might be acutely aware that they are in your neighborhood. These environmental hazards add to what we call environmental justice or injustice. And you will notice that in a lot of poor neighborhoods, this is where we stock a lot of our most toxic elements. Oil refineries, liquid gas. So notice, and you can also just do this in your own neighborhood. You can go out and just walk around and notice, where are the risks? Where are the protective factors? Do we have parks? Do we feel safe in the park? Are there green areas? Are there sidewalks? Are they well lit? Is there ample grocery stores and not just corner stores? Notice what's available to you. Do you have farmers markets? Do you have fresh produce? Do you have community gardens? Those are just some of the elements. So not only are we looking at the environment from a social justice perspective, but we're also looking at it from a healthcare perspective. That depending on your zip code is going to say whether or not you're going to have certain illnesses and whether or not you're going to live a certain length of time. And we're talking about a system of justice and injustice. We're talking about health disparity. Who gets to have health care? Who gets to have the things around them that make them healthier? It also explains why some groups struggle more than the other, and also gives a lot of reason to doubt whether or not the myth that the United States has, which is if you try hard enough, you too can succeed, is really valid. Let's suppose I live in an environment that makes me sick, that is incredibly stressful, that doesn't provide me nearly the resources other people might get. And really, all I have to do is try harder. And are you telling me that with all the resources you got, that you are trying as hard as I am? That there is a built-in injustices in our society. And a lot of what social work does is to understand that injustice and try to fix it, actually. So we're going to be looking at some videos. And what I want you to get is that balance between nature and nurture. And we still are struggling with what that balance is and what it can tell us. But some things that we do know is that we are born with genetic material which dictates a number of our characteristics. But it doesn't necessarily dictate our future. We have what's also called epigenes. They're sort of like a light switch on a wall. And they could always remain off and never be switched on. And then a certain developmental time in our life, meaning a certain time of our growth, and environmental changes or factors can turn that switch on. And then either we grow even faster because that developmental time of puberty forces us to, or we'll get more exposed to cancer because our environment has flipped the switch. So if you never work in a really toxic environment, that switch may never get flipped. But if you were poor and you don't have control over where you work, and you don't have control over the bosses to tell them that the work environment doesn't feel comfortable or safe, you more likely are going to get the other factors in that can switch it. So we're going to talk about that. We're also going to be looking at, so let's suppose if that's true, well, how much does nature have to do with this? And how much does nurture? And is there any of that that we can control?
Meet Lucky Lyle and Troubled Tim. Now you might think they look a lot alike. That's because they're identical twins. But imagine them being raised in completely different environments. As adults, they turn out very differently. Lucky Lyle is a model citizen. He goes to work, pays his taxes, treats others well, and gets an education. Troubled Tim is on a different path. He robs banks, doesn't pay taxes, and gets his first prison sentence at the same time as Lyle gets his diploma. Their genes are identical, so it must be their separate environments that have made them so different, right? Well, there's more to it than that. Much more. We need to rewind a bit in time. You see, one of the great questions of humanity is, what makes us us? Early explanations had a hint of the supernatural about them. As the centuries whizzed by, science emerged and fought a tough battle to gain credibility. Eventually, social science emerged with the popular theory that our environment is what makes us us. Let's call this nurture. Undaunted, the biological sciences presented another theory: genes, an unchangeable blueprint in you from birth, decides everything. Let's call this one nature. So, are we a product of our genes or of our environment? The battle raged on. Observations in a newer field of study suggest that both are partly right. This field is called epigenetics. It means above genetics and has to do with how nature and nurture interact. At the heart of this discussion is one simple question asked by researcher Michael Meany. What makes a good rat mama? Well, for a rat mother, nothing says love and care like some nice, vigorous licking. The higher the number of licks, the more love and the better the mama. With this in mind, the researchers compared two groups of rat mothers, one that licked their babies a lot and another that didn't. They found that when babies grew up, they carried their mama's behavior with them and passed it on to the next generation and the next one and so on. But could it
This is
simply
the
be that this
power of
particular
parenting.
group of rats was genetically predisposed to produce caring mothers? Well, to test this, the researchers took newborn babies from low-licking mothers and fostered them with high-licking mothers and vice versa. It turns out that if the mother is a high licker, the rat baby becomes a high licker too, regardless of whether it's genetically related to her or not. So genes really don't have anything to do with it then? In true scientific fashion, the researchers dove right into the brains of these rats to see what, if anything, was different in the brains of the babies of high-licking versus low-licking mothers. When they looked at genes that possibly play a role in motherly care, they found crucial differences. Newborn rat babies have clusters of molecules called methyl groups attached to these genes. These methyl groups silence the gene, effectively switching it off. The researchers discovered that while the methyl groups in rats from low-licking mothers were still attached, in the rats from high-licking mothers, these methyl groups had disappeared. This was also true for the rats that had been adopted by high-licking rat mothers. The care these rats received from their mothers actually physically altered their genetic expression. Now that's all fine and good for rats, but what about people? Well, the same is true for Lucky Lyle and Troubled Tim, and for you and me. The genes you're born with are the genes you've got. But lifestyle and environmental influences such as nutrition, exercise, smoking, stress, and love greatly affect your biology. These changes can actually be observed at the DNA level. The bright side is that epigenetic changes happen throughout our lives, and our choices can make real differences in how we develop as human beings.
This video really made it feel like a lot of those external factors were out of choice. And we will look to see if that's true further on. What are some of the other ways that our environment changes our genes?
So it all came to life in a dark bar in Madrid. And as I was stepping into the bar, I encountered my colleague from McGill, Michael Meany. And we were drinking a few beers, and like scientists do, he told me about his work. And he told me that he is interested in how mother rats lick their pups after they were born. And I was sitting there and saying, this is where my tax dollars are wasted, on this kind of soft science. But as the beer got more intense and the alcohol gets into the brain, you become more receptive. And he started telling me that when the rats, like humans, lick their pups in very different ways. Some mothers do a lot of that. Some mothers do very little, and most are in between. But what's interesting about it is that when he follows these pups when they become adults, like years in human life, long after their mother died, they are completely different animals. The animals that were licked and groomed heavily, the high licking and grooming, are not stressed. They have different sexual behavior. They have different way of living than those that were not treated as intensively by her mother. So then I was thinking to myself, is this magic? How does this work? I'm a biochemist. I believe that there are chemical explanations to nature. I was working in a field called epigenetics, But before I jumped into that conclusion, we had to do another experiment. Is this genetic, as geneticists would like you to think? Perhaps the mother had the bad mother gene that caused her pups to be stressful, and then it was passed from generation to generation. It's all determined by genetics. Or is it possible that something else is going on here? So in rats, we can ask this question and answer it. So what we did is a cross-fostering experiment. You essentially separate the litter, the babies of this rat at birth, to two kinds of fostering mothers. Not the real mothers, but mothers that will take care of them. High-licking mothers and low-licking mothers. And you can do the opposite with the low-licking pups. And the remarkable answer was, it wasn't important what gene you got from your mother. It was not the biological mother that defined this property of these rats. It is the mother that took care of the pups. So how can this work? And as I told you, I'm an epigeneticist. I'm interested in how genes are marked by a chemical mark during embryogenesis, during the time we're in the womb of our mothers, and decide which gene will be expressed in what tissue. Different genes are expressed in the brain, then in the liver, and the eye. And we thought, is it possible that the mother is somehow reprogramming the gene of her offspring through her behavior? And we spent 10 years, and we found that there is a cascade of biochemical events by which the licking and grooming of the mother, the care of the mother, is translated to biochemical signals that go into the nucleus and into the DNA and program it differently. So now the animal can prepare itself for life. Is life going to be harsh? Is there going to be a lot of food? Are there going to be a lot of cats and snakes around? Or will I live in an upper-class neighborhood where all I have to do is behave well and proper, and that will gain me social acceptance? And now one can think about how important that process can be for our lives. We inherit our DNA from our ancestors. The DNA is old. It evolved during evolution. But it doesn't tell us if you are going to be born in Stockholm, where the days are long in the summer and short in the winter, or in Ecuador, where equal number of hours for day and night all year round. And that has such an enormous amount on our physiology. So what we suggest is perhaps what happens early in life. Those signals that come through the mother tell the child what kind of social world you're going to be living in. It's going to be harsh, and you better be anxious and be stressful, or it's going to be an easy world, and you have to be different. Is it going to be a world with a lot of light or little light? Is it going to be a world with a lot of food or little food? If there's no food around, you better develop your brain to binge whenever you see a meal, or store every piece of food that you have as fat. So this is good. Evolution has selected this to allow our fixed old DNA to function in a dynamic way in new environments. But sometimes things can go wrong. For example, if you're born to a poor family, and the signals are, you better binge. You better eat every piece of food you're going to encounter. But now we humans in our brain have evolved, have changed evolution even faster. Now you can buy a McDonald's for $1. And therefore, the preparation that we had by our mothers is turning to be maladaptive. The same preparation that was supposed to protect us from hunger and famine is going to cause obesity, cardiovascular problems, and metabolic disease. So this concept that genes could be marked by our experience, and especially the early life experience, can provide us a unifying explanation of both health and disease. But is it true only for rats? The problem is we cannot test this in humans, because ethically we cannot administer child adversity in a random way. So if a poor child develops a certain property, we don't know whether this is caused by poverty or whether poor people have bad genes. So geneticists would try to tell you that poor people are poor because their genes made them poor. Epigeneticists will tell you poor people are in a bad environment or an impoverished environment that creates that phenotype, that property. So we moved to look into our cousins, the monkeys. My colleague Stephen Sumi has been rearing monkeys in two different ways. Randomly separated the monkey from the mother and reared her with a nurse in a surrogate motherhood conditions. So these monkeys didn't have a mother, they had a nurse. And other monkeys were reared with their normal, natural mothers. And when they were old, they were completely different animals. The monkeys that had a mother would not care about alcohol. They were not sexually aggressive. The monkeys that didn't have a mother were aggressive, were stressed, and were alcoholics. So we looked at their DNA early after birth and see, is it possible that the mother is marking? There is a signature of the mother in the DNA of the offspring. These are TA14 monkeys. And what you see here is the modern way by which we study epigenetics. We can now map those chemical marks, which we call methylation marks, on DNA at a single nucleotide resolution. We can map the entire genome. We can now compare the monkey that had a mother and not. And here's a visual presentation of this. What you see is the genes that got more methylated are red. The genes that got less methylated are green. You can see many genes are changing because not having a mother is not just one thing. It affects the whole way. It sends signals about the whole way your world is going to look like when you become an adult. And you can see the two groups of monkey extremely well separated from each other. How old? How early does this develop? These monkeys already didn't see their mother, so they had a social experience. Do we sense our social status even at the moment of birth? So in this experiment, we took placentas of monkeys that had different social status. What's interesting about social rank is that across all living beings, they will structure themselves by hierarchy. Monkey number 1 is the boss. Monkey number 4 is the peon. And you put 4 monkeys in a cage, there will always be a boss and always be a peon. And what's interesting is that the monkey number 1 is much healthier than monkey number 4. And if you put them in a cage, monkey number 1 will not eat as much. Monkey number 4 will eat as much. And what you see here in this methylation mapping, the animals that had a high social status versus the animals that did not have a high status. So we are born already knowing the social information. And that social information is not bad or good. It just prepares us for life because we have to program our biology differently if we're in a high or the low social status. But how can you study this in humans? So we can't do experiments, we can't administer adversity to humans, but God does experiments with humans. And it's called natural disasters. So one of the natural disasters, the hardest natural disaster in Canadian history happened in my province of Quebec. It's the ice storm of 1998. We lost our entire electrical grid because of an ice storm when the temperatures were in the dead of winter of Quebec, -20 to -30, and there were pregnant mothers during that time. And my colleague Suzanne King followed the children of these mothers for 15 years. And what happened was that as the stress increased, and here we had objective measures of stress, how long you were without power, where did you spend your time, was it in your mother-in-law apartment or in some posh country home? So all these added up to a social stress scale, and you can ask the question, how did the children look like? And it appears that as stress increases, the children develop more autism, they develop more metabolic diseases, and they develop more autoimmune diseases. And we will map the methylation state, and again you see the green genes becoming red as stress increases, the red genes becoming green as stress increases, an entire rearrangement of the genome in response to stress. So if we can program genes, If we are not just the slaves of the history of our genes, but they could be programmed, can we deprogram them? Because epigenetic causes can cause diseases like cancer, metabolic disease, and mental health diseases. Let's talk about cocaine addiction. Cocaine addiction is a terrible situation that can lead to death and to loss of human life. We ask the question, can we reprogram the addicted brain to make that animal non-addicted anymore? We used a cocaine addiction model that recapitulates what happens in humans. In humans, you're in high school, some friends suggest you some cocaine, you take cocaine, nothing happens, months pass by, something reminds you of what happened the first time, a pusher pushes cocaine, and you become addicted, and your life has changed. In rats, we do the same thing. My colleague Alia did. He trains the animals to get used to cocaine. Then for 1 month, no cocaine. And then he reminds them of the party when they saw the cocaine the first time by cue, the colors of the cage when they saw cocaine, and they go crazy. They will press the lever to get cocaine till they die. We first determined that the difference between these animals is that during that time when nothing happens, there's no cocaine around, their epigenome is rearranged, their genes are remarked in a different way, and when the cue comes, their genome is ready to develop this addictive phenotype. So we treated these animals with drugs that either increase DNA methylation, which was the epigenetic mark we look at, or decrease epigenetic markings. And we found that if we increase methylation, these animals go even crazier. They become more craving for cocaine. But if we reduce the DNA methylation, the animals is not addicted anymore. We have reprogrammed them. And the fundamental difference between an epigenetic drug and any other drug is that with epigenetic drugs, we essentially remove the signs of experience. And once they're gone, they will not come back unless you have the same experience. So the animal now is reprogrammed. So when we visited the animals 30 days, 60 days longer, which is in human terms, many years of life, they were still not addicted by a single epigenetic treatment. So what we learned about DNA, the DNA is not just a sequence of letters. It's not just a script. DNA is a dynamic movie. Our experiences are being written into this movie, which is interactive. You're like watching a movie of your life with the DNA with your remote control. You can remove an actor and add an actor. And so you have, in spite of the deterministic nature of genetics, you have control of the way your genes look like. And this has a tremendous optimistic message for ability to now encounter some of the deadly diseases like cancer, mental health, with new approach, looking at them as maladaptation, that if we can epigenetically intervene, reverse the movie by removing an actor and setting up a new narrative. So what I told you today is that our DNA is really combined of two components, two layers of information. One layer of information is old, evolved for millions of years of evolution. It is fixed and very hard to change. The other layer of information is the epigenetic layer, which is open and dynamic and sets up a narrative that is interactive. So even though we are determined by our genes, we have a degree of freedom that can set up our life to a life of responsibility. Thank you.
In addition to epigenetics, which tells us that we do have a genetic framework, but we also can be directly impacted by our environment, which actually can change our genes. Another way of looking at this is through the social determinants of health. In fact, everything that social work does is around the social determinants of health. whether it's addiction, poverty, violence. We're constantly dealing with environmental issues that impact a person's well being. This is another perspective, and one that you will see much more in the hands on aspects of social work.
Camden, New Jersey sits in the shadow of Philadelphia. It's a city that seems in a constant state of peril. Poverty here is rife. Unemployment is double the national average. Public institutions are in crisis, or, like the local library, simply shuttered. It's officially one of America's most dangerous cities. But Camden may also be the city to help solve one of America's most intractable problems, lowering the cost of healthcare. As a doctor and writer for The New Yorker, I came here to meet the local physician who began to figure it out. It all started 10 years ago with a shooting.
I was working in my house one evening, heard gunshots, then got a call from a neighbor. So I went running down the street. The police had gotten there already. So I ran up and said, I'm a physician, where's the victim? And they all sort of turned around and said, he's over there.
What is the location?
He was laying on his side facing the back tire, and he had a pulse. He wasn't breathing, started rescue breathing. Eventually his pulse stops. So I was just pretty overwhelmed by the whole thing and angry. And
You were angry that they hadn't been even tending to the victim.
I said, why didn't you guys help him? And the police officer said, we didn't want to dislodge the bullet. I mean, it was just a complete blow-off. And I couldn't imagine how we could have reached the point in our society, in this city, where you would just leave a victim lying there in their own blood. He was a Rutgers student, and he was close to graduating. He was one of the wonder kids that make it out of urban communities. And here he was just about to make it out.
Brenner's immediate response was to get involved in police reform. He thought if he could get a hold of crime statistics, he could map hotspots, the places where good policing would make a difference. But the department wasn't interested in helping a local doctor. So he went to another place, one he knew well, the hospital. There, buried in billing records from the ER where violent assaults get treated, he found crime patterns. As he crunched the hospital data, Brenner discovered something totally unexpected: other kinds of hotspots.
It became clear that there were hotspots of everything. There were hotspots by disease, hotspots by patient. There were certain patients who'd been over and over and over going to the emergency room and hospital too much. There were hotspots by zip code and by neighborhood. And so you sit and begin to look through the data, and I'm looking at my patients who are in the data and realizing I had no idea how much healthcare cost. I had no idea how expensive it was, and it was just shocking.
Brenner says the numbers showed that 1% of people living in Camden accounted for 30% of hospital charges, most of those racked up in the emergency room. So you're compiling all of this information coming from all of the hospitals in the local area.
Compiling massive amounts of data, so a full...
Brenner then turned that raw information into visual information.
So this is a map of the city of Camden, and this is looking at cost data. So the red areas are high-cost hotspots. These are parts of the community where people who have more than $1 million in payments to the hospitals live, and this is over a 5.5-year period.
So here you pulled out the two most expensive city blocks.
Yep.
But you found in your community there are two buildings
That's right.
that are the most expensive places.
That's exactly right. So the building on the bottom, Abigail House, is a nursing home. And the top one, Northgate 2, is an apartment tower with elderly and disabled people.
$83 million in bills.
That's right.
It's probably more than the cost of the building.
Yes. Yep.
This being America, where we all demand the best that medicine can offer, you might assume that at least for the money, the residents were getting good care. But Brenner found the majority of the care for chronic diseases, from asthma to cancer to diabetes, was being done in the ER. Not a good place. to treat chronically ill patients. Treatment was not coordinated, follow-ups were not part of the plan.
It was really obvious in the data that the most expensive people were getting terrible care. And I knew them, so I'd walk in the exam room and say, Mrs. Rodriguez, I haven't seen you in 3 months. Where you been? Well, I've been in the ICU for a month and a half. I've been in the hospital for another couple of weeks. And I'd said, well, what happened? And she'd say, well, I'm not really sure. A lot of doctors came in the room. They never really explained anything to me, but I've got this whole bag of medicine. So American healthcare doesn't do a good job taking care of sick people. The way we built our system is really a system that's very hard to access. It works well for the average patient, but if you are blind, if you're deaf, if you're disabled, if you're in a wheelchair, if you don't speak the language, if you're developmentally delayed, if you have a complex mix of illnesses with many providers involved, the whole system starts to break down.
Brenner's big insight was to use his data to target the sickest and most expensive patients in the city. In 2007, supported by small grants from foundations, he put together his team of medical hotspotters.
Hey, Angela, it's Kathy Jackson giving you a call from the Coalition. I was wondering if you had a chance to do your blood glucose logs.
The most visible part of the Camden Coalition of Healthcare Providers are these nurses, social workers, and medical assistants.
It's also important to show that he was really going all over the state.
Yeah, wherever.
3 years later, his team of troubleshooters has sought out and organized care for more than 300 people.
Make sure we have transportation that's going to be able to accommodate a disability.
When I visited, Kathy Jackson was making a house call to one of her most challenging patients, Derek.
Do give me the briefing on Derek, because I haven't met him yet.
So Derek's in his 30s, and he has seizure disorder.
Okay. Yeah.
And then his other problem, which gets him in the hospital most of the time, is asthma. It's always an issue. He's always wheezing, and the house it's dirty, it's dusty, roaches, all kinds of triggers. So we took a contractor there, and the contractor said that he really wouldn't want to be liable to fix it up because he's afraid it would actually crumble. Hey Derek, how you doing? Yeah.
I'm Atul Gawande. I'm a doctor from Boston, but also a writer. So Derek, you've had a number of hospital stays and emergency room visits because of asthma, I hear.
Right.
What happens when you have your asthma attack?
When I start wheezing, my lungs are actually, it's like a rubber band. It just closes up really tight, and it'll be hard for me to breathe.
We think the house probably is part of it. There's a lot of dust with the walls, the open walls, and...
Would you mind, Derek, if I have Kathy just show me around the places in the house that she thinks might be contributing to your asthma?
Yeah, sure.
Okay. That'd be great. I'd just like to see for myself.
Okay.
Yeah.
You want to lead the way then?
Before Kathy started working with him, Derek was in the emergency room 35 times over 6 months.
Oh yeah, lots of mold here. That cannot help your asthma.
Kathy's work with Derek includes everything from inhalers to insurance to finding a contractor willing to rehab the house. Why don't we just say, Derek, fix your house. You've got this and that falling apart.
His family probably lives on about $1,000 a month. So they're not really capable. They're barely able to make ends meet.
Without the team, Derek didn't have enough help with another medical problem: epileptic seizures.
What are all the crosses?
No, that helps me, in case if I have an epilepsy.
How does that help you?
No, I just start praying, that's all.
Oh yeah?
Mm-hmm.
Wow.
Have you had any seizures recently?
No.
Okay. How long has it been? A week, a month?
Weak. I feel more comfortable with Kathy Jackson than the doctors and nurses in the hospital. I can tell Kathy my problems, I'm wheezing and stuff like that. She checks me out, hear my lungs, talk to me.
As always, you always have some wheezes, but you're moving pretty good air, so that's good.
She's the one that keeps me out the hospital.
We're going to come back in 1 month, June 13th at 11 o'clock.
Under Kathy's care, Over the last 6 months, Derek's ER visits have been reduced from 35 to just 2.
See ya.
And Brenner thinks they can do even better if he can get other people from around the city to think like hotspotters.
We've formed this as really a way of beginning to think agency by agency how we can pull together for the most challenging cases. Every month the whole city comes together, frontline providers, social workers, and we do anonymous case discussions at the city level.
Substance abuse initiative.
So when someone like Derek shows up at one of the emergency rooms, they'll call us right away.
Actually, in 2011, he had 2 hospitalizations, and none in April, and only 1 since May. And
So how much has your team been able to lower the costs for this really expensive group of patients?
So we've seen some preliminary results of 40 to 50% reductions in visits and cost. We're now
40 to 50% reduction in costs.
in cost and visits.
The savings are hard-won, and it takes persistence.
Mr. Harris, it's Kelly and Anna from the coalition.
You can't completely alter people's life circumstances. We're not going to cure poverty. The question is, how can you take the current situation that a patient's in and improve it enough to make them a little bit healthier and lower their unnecessary ER and hospital use and make them have a more productive interaction with the healthcare system.
Do you see anything?
This idea of focusing on the sickest to lower costs for everyone seems to be working here in Camden. But there are hotspots in every community. What if you took this idea and put it in play across the country? It might just work, but there's a catch. How would the medical establishment react if suddenly their most expensive and lucrative patients started costing half of what they do now?
As this kind of an experiment works, though, you're talking about dropping the number of hospital visits as a whole.
Yes.
You're talking about removing people from emergency rooms.
Yes.
They could have to shut down floors and beds. They're
Yes.
not going to be with you on this, are they?
This kind of work is a game changer, and this is a blockbuster video moment for America's hospitals.
What do you mean by a blockbuster video moment?
So along comes Netflix, and there had to have been a moment when a young executive walked in and said, hey, they're starting to rent videos online, and Blockbuster said, nah, people like coming to the video store. We're not going to make any change. So disruptive change comes along, and I think better care for sick people is disruptive change. We have inflated a capacity bubble in our country to do expensive, high-tech, hospital-based care.
So what's your ultimate goal here?
So I'd like Camden to be the first city in the country that bends the cost curve dramatically while improving quality. Because if the poorest city in the country can do it, it makes the rest of the country look silly.
This next video also looks at the differences that happens in neighborhoods, but it walks you through some of those crucial differences.
What determines how long we'll live? Is it what we do? Is it who we are? Actually, when it comes to predicting how long you'll live, your zip code is more important than your genetic code. Here's how this works. Meet Deb and Maria. They both have jobs, they're around the same age, they're both married, and they both have 2 kids. Deb lives in A-Town, while Maria lives in Bville, less than 1 mile away. They're similar in so many ways, but here's the thing. On average, residents of Bville will die more than 15 years sooner than the residents of A-Town. Why? Because where you live is about more than just your address. It's about your opportunities. For example, Deb and Maria's access to healthy options is really different. In A-Town, Deb's family is surrounded by healthy food options, including farmers markets, specialty shops, and grocery stores. The air in A-Town is cleaner and fresher. And there are lots of safe, clean parks where Deb can exercise and her children can play. A-Town has good public schools for Deb's kids and easy access to emergency and preventive health care. On the other hand, Beeville has broken, badly lit sidewalks, and the parks are unsafe. The air is filled with truck exhausts from the nearby highway. And for food options, Maria's only choices are Beeville's many liquor stores, fast food places, or convenience stores. The schools in Beeville are overcrowded and undersupported. And even if Maria can get her kids into better schools far away, she needs to figure out how to get them there without access to a car. So for Maria, having to juggle so much to find healthy options can be an overwhelming source of chronic stress, which is a serious health risk factor. In fact, for all the residents of Beeville, chronic stress drives health problems like obesity, diabetes, asthma, and heart disease. How did A-Town and Beeville get so different? Well, in many cases in cities and towns across California, the root cause was racial and economic discrimination. Over the generations, poor white people and people of color were pushed to less desirable parts of town, where banks refused to lend money, businesses left, jobs too, schools declined, and the neighborhood crumbled. Everyone who could move away did. And what's more, when communities like A-Town and Beeville are so unequal, Beeville isn't the only one that suffers. Because it turns out that not only is your zip code a predictor of how long you'll live, so is what country you live in. Countries with the greatest income inequality have the lowest life expectancy. So even Americans like Deb, who are white, insured, college-educated, and upper income, die younger than their peers in other countries. In fact, our life expectancy is 43rd in the world, and that number is slipping. In the end, our biggest health risk may actually be inequality, and extreme inequality hurts us all. So what do we do? Well, if we're all going to be healthier, we don't just need to help the folks in Beeville beat the odds. We need to change the odds for everyone. And that's what we're doing. There's a movement happening. We're Californians. We don't follow. We lead. We are building the power to make health happen in communities across the state. We are coming together to build one California, a smarter, more inclusive and equitable state that creates health and opportunity for all of us. Join us. To learn more, visit buildinghealthycommunities.org.
Another important reason that we need to understand biology is that many of the co-current conditions that we're going to be looking at as social workers seem to have organic bases. Depression, anxiety, bipolar, how much of this is changeable, how much of this is fixable by a medication. What does the medication do? And what happens when a client comes to you and they talk about some of the side effects they're having or some of the positive effects they're having? How do you know how to assess that? How do you know how to coach or support someone in their treatment unless you know some aspects of biology? So we're going to look at this short video on moods and medications, and it's just an intro. You could have easily a whole course on itself. In addition, when we're working with people, they're often struggling with chronic illnesses, and the more we can understand the mind-body connection, how chronic illnesses affect people's moods and their ability to synthesize new information is going to be incredibly important for us. And later, when we talk about trauma, you'll also see that that's a whole medical and biological feature as well. So understanding human biology goes far deeper than understanding the systems of the cell.
Mood naturally fluctuates, and everyone experiences highs and lows in their lives. But in some cases, changes in mood can become long-lasting, debilitating, and can impair someone's ability to hold down a job or sustain meaningful relationships. It's estimated that around 10% of people will at some point in their lives suffer from depression, a mood disorder characterized by several symptoms. Feeling sad, distressed, unmotivated, excessively tired, and losing interest in once pleasurable activities known as anhedonia. Many people with depression also suffer from anxiety. Neuroimaging studies reveal that many brain circuits that normally regulate mood are dysregulated in depression. Located deep within the brain, the amygdala processes highly salient stimuli such as rewards and potential threats. In depression, the amygdala is overactive and responds excessively to negative events. In turn, the amygdala connects to a set of brain regions that hone the physiological and behavioral response to emotional stimuli. These areas include the medial prefrontal cortex, the nucleus accumbens, the hippocampus, and the insula. The hippocampus is involved in memory formation, and along with the prefrontal cortex is particularly vulnerable to the effects of stress. Depressed people are more susceptible to stress, which can cause physical changes in the brain, including atrophy of the hippocampus. This and other changes in depressed people may cause inappropriate responses to emotional events. The medial prefrontal cortex is involved in regulating how strongly we react to emotional stimuli. Treatments such as antidepressant drugs, cognitive behavioral therapy, and electroconvulsive therapy affect the structure and function of these and other brain regions. Animal models such as mice are critical in helping us understand the cellular and molecular changes underlying depression and develop better treatments. Although it's impossible to know if a mouse is depressed, mice subjected to chronic stress show some symptoms similar to depressed humans, such as anxiety-like behavior, less social interaction, and a lack of interest in normally pleasurable activities. While not all human depression is triggered by stress, these models may still shed light on the biology of depression, and they're the closest scientists can get while studying mice. As with humans, chronic stress in mice can lead to atrophy of the hippocampus and prefrontal cortex. Mouse studies have also shown altered neuronal plasticity in various brain regions, including the hippocampus, prefrontal cortex, amygdala, and nucleus accumbens. In a healthy hippocampus, experiences can lead to changes in the connections between neurons, resulting in learning. These changes are referred to as plasticity. Chronic stress can reduce this plasticity. Healthy brains also continue to produce new neurons in one part of the hippocampus. These new neurons slowly mature and integrate into the circuitry, where they have a strong effect on hippocampal activity and behavior. These new neurons are also affected by stress. They're reduced in number in stressed brains. These effects may result from reduced levels of neurotrophins, proteins that increase neuronal growth and plasticity. Reduced plasticity may stop the hippocampus from being able to properly regulate the stress response, which may lead to a vicious cycle where stress perpetuates more stress. The hippocampus is particularly affected, but there can be reductions in plasticity elsewhere in the brain, and together these changes could contribute to other symptoms of depression like anhedonia. Whether these cellular changes seen in mice are involved in human depression remains unclear. Most antidepressants available today rapidly increase the amount of the neurotransmitters serotonin and/or norepinephrine in the synapse. However, improvements in symptoms in patients and mice usually don't occur until weeks after starting the treatment. While the reasons for this delay aren't fully understood, prolonged treatment with antidepressants can, over time, act to reverse some of the changes induced by chronic stress, increasing neurotrophin expression and rebooting hippocampal plasticity. Non-chemical treatments for depression, including electroconvulsive shock, also promote hippocampal plasticity in mice. Antidepressant treatment can also reverse stress-induced changes in other areas of the brain, including the prefrontal cortex and reward circuitry. Different treatments may target different regions to improve symptoms. Recently, the drug ketamine was found to have rapid antidepressant effects in patients with depression as well as in rodent models, with effects lasting for days. The mechanism behind this is an area of active research. Ketamine blocks a type of synaptic transmission, leading to activation of a number of signaling pathways and increasing neurotrophin expression. These molecular changes result in increased plasticity in the prefrontal cortex and hippocampus and likely contribute to ketamine's behavioral effects. By studying the changes in the brain caused by chronic stress and how antidepressants like ketamine work to reverse them, researchers may find new targets for treatment or new drugs that could act more quickly, more specifically, or more effectively than currently available treatments.
The use of medication at any time is very controversial. The causes of depression and anxiety and bipolar are very complex. We'll explore more of these issues later. In this one, I just wanted to get you an idea of all the ways, not even all, just some of the ways that understanding our biological self matters in social work.